Good morning all. I am Dr. Kartika Maheshwari, Assistant Professor from ABES Engineering College, Department of Applied Science and Humanities. Today my topic of discussion is Schrodinger wave equations. So Schrodinger wave equations. In 1926, Schrodinger presented two famous wave equations. First is time-independent Schrodinger wave equation and second is time-dependent Schrodinger wave equations. Uh, these two equations represent the variation of de Broglie matter waves, and these equations describe the various properties of matter waves. So we discuss today time independent Schrodinger wave equation. Let us assume that psi xt. Let us assume that psi xt is a wave function associated with a particle moving in positive x direction, which represent the variation of matter waves. So that the general wave equation for EM waves are del square E over del x square is equal to 1 upon c square del square E over del t square. This is the general wave equation for electromagnetic waves or for light waves. Light waves travel with the speed of light. So C is the speed of light. Similarly, for matter waves, the general wave equation is del square psi xt over del x square is equal to 1 upon v square del square psi xt over del t square, where psi xt is the wave function which represents the variation of matter waves. The wave is moving in the positive x direction, and v is the velocity of matter waves. This is second order differential equation. So the solution of this wave equation is psi xt is equal to psi naught e की power I k dot kx minus omega t. This is the solution of this wave equation with the wave is moving in the x direction, where psi naught is the amplitude of the wave and k is the propagation constant and omega is the angular velocity. Now differentiate equation 1 twice with respect to t. So del psi xt over del t is equal to the differentiation of e की power x is e की power x. We get psi naught e की power I kx minus omega t, and that is minus I omega. Once again, if we differentiate it with respect to d, what we get? Del square psi xt over del t square is equal to minus I omega square psi naught e की power I kx minus omega t. We can write this as psi xt. So del square psi xt over del t square is equal to minus square is plus I square omega square psi xt. That is del square psi xt over del t square is equal to minus omega square psi xt. Put this value in general wave equation for matter waves. So put this value in general wave equation. That is del square psi xt over del x square. We get minus omega square v square psi xt. Or we can write it as del square psi xt over del x square plus omega square v square psi xt is equal to 0. This is equation 3. Now we have to find the value of omega square over v square. We can write it as omega is 2 pi nu and velocity in terms of frequency is nu lambda square. So it is 4 pi square nu square over nu square lambda square. According to de Broglie hypothesis, lambda is equal to h upon p. So omega square v square is equal to 4 pi square lambda square is h square upon p square. That is, we get 4 pi square p square h square. Now, in terms of energy, the total energy of particle is the sum of kinetic energy plus potential. We represent potential energy and K is kinetic energy. And in terms of momentum, we can write as kinetic energy is P square upon 2m plus V. So, the value of P square momentum is 2m E minus V. Now, omega square V square is equal to 4 pi square lambda square, or it is 4 pi square h square p square. Now we know that p square is equal to 2m e minus v. So we can write it as 4 pi square 2m e minus v over h square. So omega square v square is equal to 8 pi square m h square e minus v. Put this value in equation 3. So what we get, put this value in equation 3. We get del square psi xt over del x square. Omega square v square is 8 pi square m h square e minus v. So we get 8 pi square m h square e minus v over psi xt, and it is equal to 0. So this is Schrodinger time independent equation where E is total energy, V is potential energy. The energy is in this, the energy of particle is independent on time. So there is Schrodinger time independent equation where psi xt is the wave function which represent the variation of matter waves. Like electromagnetic waves, material particles also have a wave associated with it, and the variation of this wave is represented by wave function, that is psi xt. The Schrodinger equations plays the same role in quantum mechanics as Newton's law play a role in classical mechanics. So for free particle, the potential energy is 0. So Schrodinger equation for free particle is del square psi xt over del x square plus 8 pi square m over h square e psi xt. So this is Schrodinger equation for a particle, for free particle. So we have derived Schrodinger time independent equation. In the next lecture, we discuss the Schrodinger time dependent wave equations. These are the references which we used. So thank you. In the next lecture, we discuss Schrodinger time dependent wave equation.